So this is the introduction to topic 19, solving radical equations. And we're going to look at page 104, and there are two main parts to this. So the first thing we're going to look at is the squaring property of equality, which we need to use in order to solve radical equations. And then we're going to see an example of how we apply this. So first of all, let's go to the squaring property of equalities. So to solve equations containing the square root radical, we use this squaring property. If we know that A equals B, if we square the left side, we get A squared. If we square the right side, we get B squared. If the square property is used on an equation, the solutions of the squared equation will include all the solutions of the original equation plus possibly some extraneous solutions. What does that mean? Extraneous solutions are solutions that do not work when substituted back into the original equation. We're going to see an example of this on the following page on the next video. Example 1 on page 5. But basically we solve an equation and then we can't put it back into the original equation so that it checks left side equals right side. Then we call it an extraneous solution. So let's take a look at some applications of this rule that if A equals B, then A squared equals B squared. Let's say we have a variable x, square root of x equals square root of A. Then we square both sides. We square this side and we square that side, which is what we're doing over here. What does that mean? We're multiplying the root of x times the root of x. That means the root of x squared here. So what we're doing when we do this is we're doing that. In the same way that the root of A squared means multiplying the root of A by itself. Now, when we multiply the root of x by itself, we get x squared, because both of these we can put them under the root side and we get x squared. And the same thing is true here. The root of A times the root of A is the square root of A squared. Square root of x squared is x, and the square root of A squared is A. So that's one example. Supposing we have x plus y equals the root of A, and then we use the property of squaring both sides. Here I squared both sides. So I take this equation, this term, and I square it, I get this. I take this term here and I square it, I get that. So essentially what this means is take x plus y and multiply it by itself. Take the root of A and multiply it by itself. Now this multiplied by this under the root sign gives me x plus y squared. Root of A times the root of A gives me A squared. Now the square root of x plus y squared is x plus y, because essentially this square root term cancels this term and you're just left with this. And similarly the square root of A squared is A. So we're going to see some examples as we go along, not only on other pages, not only page 104, 105, and other pages associated with topic 19. Now let's see the example, and it says isolate a radical. That's very important, to isolate the radical. So, and use the squaring properties. We're going to explain why. Simplify and repeat if necessary. If you still have another square root sign, do it again. Solve the resulting equation and check all the equations, all the solutions in the original equation. Reject any extraneous ones, means ones that don't work. Okay, so here we have the root of x plus 1 minus 3 equals 0. Now, if we were to square the left side by itself, it will be difficult to square. We're not saying that we can't do it, but it would result in 3 terms, and we would still have a square root sign left. Try and do that on your own. In other words, you're going to multiply the first by the first, the last times the last, but your middle terms will still involve a root sign. Now, if you, on the other hand, transpose the -3 to the other side, and we get this, squaring it, which is what we're doing when we isolate the radical. So now we've isolated the radical with the unknown by itself. This number 3 is now on the other side of the equation, so we've isolated this term. That's what it means. We square both sides, and that's the rule we just learned. We square this one, and we square this one. Well, the square root of x plus 1 all squared gives us x plus 1. 3 squared gives us 9. We transpose the plus 1 to the other side. X is equal to 9 minus 1, and x is 8. Now, if we substitute 8 plus 8 into the x position here, and replace x with 8, we get the square root of 8 plus 1, which is the square root of 9. And 3 minus 3 is 0. This is really the left side of the equation, and this is really the right side of the equation. 8 plus 1 gives square root of 9. Square root of 9 is 3. We still have the -3. So the 3 is a valid solution. There are no extraneous solutions on this. So this completes our discussion of page 104.